Hello everyone, in this video we are going to talk about Docker networks. So when you create containers, have you ever noticed that your container is assigned an IP and you can use that IP to connect or communicate with your container? So let's try this out first. So let's see what are the images I have. I have a one Apache image, Apache latest HTTPD latest image. So I'm gonna start a container, Docker run, give it a name, Apache, and then the image name t latest. So now the container is started. This is the basic command that we use to start a container. And see, you can see here we don't specify any network details in this command, but if you inspect your container, this is the command that we use to inspect a container, docker container inspect, and after that we give the container name. My container name is Apache. So it will list down a lot of details about your container. So basically we use this inspect command when there is a requirement for a troubleshooting kind of things. So because it will allow us to see a lot of details about the container, and one detail is the IP address. So let's try. As you can see, there are a lot of details about the container. Under the network section, you can see it has an IP address 172.17.0 and 2. So this is the container running. I have only one container, Apache. So it has the IP of 172.17.0.2. So let's try to access this IP from the browser. So I open the Firefox and I'm gonna give the IP here, HTTP 172. Yeah, yeah, you can see it is working. Let's see what we have done so far. We have started a container using a very basic command here, docker run itt name, and then give it a name and then the image name, but we didn't specify any network details along with this command. But you have realized that your container is assigned an IP, and we try to connect to that IP from the browser and it is working. So now let's see what is happening in the background. So when you start a container, if you do not specify any network details along with your starting command or docker run command, your container will be assigned to the Docker default networks. So Docker has a default network which is usually running on this particular subnet 172.17.0.0 and subnet mask is 16. So it looks like this. So in your host machine, when you install the Docker, it will create a default network which is an internal network to your host machine. So this network is isolated from other networks, so other softwares running on your server. So what happens when you create a container is it is assigned to this network. So from this network your container is assigned an IP. So as I mentioned here, usually the Docker default network subnet is 172.17.0.0 and subnet mask of 16. So let's quickly go back and check our container IP that we have created. Docker container inspect, and then the container name Apache, and I can grep IP address. Okay, so you can see it is 172.17.0.2. That means it is from this subnet 172.17.0.0. So this is about the Docker default network. What if you need to have a different subnet or different IP address for your container? Can we do that? Of course we can do. You can have many number of custom networks within the same host. So as you can see in the picture here, Docker default network is there. You can create another custom network which has the subnet of 192.168.10.0 and 24 is the subnet mask. Similarly, you can have custom network 2. Likewise, you can create many more custom networks as you wish. So I think at this point you have got some idea about how these IPs are assigned to containers and what kind of networks we have the default networks, and you can also create custom networks if you wish. So let's move into some theory parts first. So Docker networks are enabled by default. That's what we have seen before. Whenever you create a container without specifying any network details, your container is assigned to the default Docker network, and your container will get an IP from there. So, and also, as I mentioned earlier, you can create custom networks in your Docker host. That is also possible. This is another very good layer of security for your workloads. As you can see, so your workloads are isolated from a network level. So which is a really good security feature comes with the Docker. So you can really easily isolate your workloads using their own networks. That is another advantage we get. And containers within the same network can communicate with each other using private IPs. If the containers are in the same network, as an example, in this network, Docker default network, you can see three containers are there. So these containers can communicate with each other using their private IPs. But these will not be able to communicate to the containers which are inside the custom network one. There are ways to do that, but it's not enabled by default. There are 2 points that you need to keep in mind here. One thing is that container knows nothing about the other containers in the network. What it does know is it does know it has an IP, and it does know there's a network interface, and it does know there's a gateway. What is the gateway? And it does know some basic network details like DNS service and all. It doesn't know anything about other containers which are running in the network. So let's look at some command examples. Creating a network, you can use the command docker network create and then d. So this dash d specifies the network driver. There are a set of network drivers available in Docker, so we will look into them in next few slides. And after that, you give the network name. So to list down all the Docker networks, you can use command docker network ls, and to attach a container to a network, you can use a command docker run and then dash dash network and the network name here, and after that the remaining commands. You can see this is the default command that we use to start containers. Earlier when we do the practical, you can remember that we didn't specify this network stuff here. We just remove this part and we just ran the command docker run and then itd and dash dash name and gave it a name and then image id. That was it. So that's why my container was automatically assigned to the Docker default network. Okay, let's try something. Okay, let's list down the networks available in my machine. So I'm going to use docker network ls. You can see I have only three. So these three actually the default set of networks: bridge, host, and none. These comes when you install Docker. So these are not something that we have created. That means these are not custom created ones. These are default networks comes with Docker. Let's try to create a network here. I'm going to use the command docker network and then create, and then I'm giving the driver type. So I'm going to give it as a bridge, and then the network name bridge network 1. Okay, now the network is created. Now let's again list down the networks. Docker network ls. You can see now my network has been created here. So how do I know what is the IP of this network? You can remember that we used a command called inspect before with a container. Similarly, for the network also you can use the same command. Then the command will be docker network inspect and then the container name. So this will list down a lot of details about the networks, including subnet details. So you can see it has the subnet 172.18.0.0 and subnet mask is assigned as 16. So now I have created a network. Now what I'm going to do is I'm going to start a container and assigned or connect that container to this network. That means to the network that I have just created, bridge network 1. To do that, I'm going to use this command docker run and then give the network name, bridge network, and then ITT, and then give it a name. I'm going to give it my container1, and then the image name is httpd we have, and enter. Now it is created. Now ideally what should happen is this particular container, the container 1, should be assigned to the bridge network 1, and this should get an IP from the subnet of bridge network 1. So let's inspect the containers first. I have two containers now, Apache container and the container 1. Apache is from the Docker default network, and this is from the custom network that we have created. Okay, let's find the IP of this container. I'm going to use the docker inspect command, container inspect, and then the container name, and then grep IP address. Oh, you can see now it has the IP of 172.18.02. So this IP is from the subnet of new network that we have created, bridge network 1. So let's try to access this one also from the browser. 172.18.02. You can see it is also working. So we created a Docker network, and then we found the command to list down all the networks in the host, and then we created a container and assigned it to a custom network. So what if you have a requirement to customize these subnet details, and whenever you start a container you need to specify the IP address too? How can we do that? So let's try that out. So I'm going to create another network, another custom network with custom subnet details. So I'm using the command docker network create, and then driver bridge, and then give the subnet details, subnet and 192.168, maybe 10, 0 and 24, and I'm going to give the name bridge network. I will give it 2. You can see it is created now. Let's check the networks available in my machine. As you can see, the bridge network 2 is there. I'm going to inspect that one, docker network inspect, and the bridge network 2. So it should have the subnet of 192.168.10.0 and 24 is the mask. So you can see the subnet details here, 192.168.10.0.24. Now what I'm going to do, I'm going to create a container to run with the custom IP, and I'm going to give the network as bridge network 2. Then I'm going to specify the IP 192.168, and then 10 and 2, and then the basic command details, the name, container 2, and httpd. You can see it is created, and sorry, you can see now I have 3 containers. This is the one I just created. So let's inspect that container. Container 2, I'm going to grep the IP address. You can see it has the IP that I gave, I specified 192.168.10.2. So let's try to access this one also from the browser. Yeah, it is working. Okay, now you know how to create a custom network, how to create a custom network with custom subnet details, and how to attach a container to a custom networks, and how to specify an IP IP and attach them to a custom networks too. So let's look at more details about network drivers now. So first we have the bridge network driver. So bridge is the default Docker network drive, and this is the most commonly used network driver. That means most of your workloads you will have to use bridge network, and you can use it to isolate your environments from the host machine and from the other Docker networks within the host. And this is mostly used if your container workload wants to communicate with other containers which are running on the same host. So this fits for the containers that do not require special networking capabilities. Then we have the host network driver. So if you use the host network driver, this removes the network isolation between your host machine and the container. It is quite like your container directly running inside the host machine as a separate process. We will look into this one in an example. And then you can use non-network driver. So using non-network driver, you can completely isolate your containers from other containers and from the host. Then there will be no communication available with this container. And then you can use IPVLAN. So this provides the full control over IPv4 and IPv6 configurations. So this fits if your containers need special network capabilities. Then MAC-VLAN. So MAC-VLAN assigns a MAC address to your containers, so your container will act or container will appear like a device in the network. So this is the last network driver we have, overlay driver. Overlay driver is used to connect multiple Docker daemons together. So the containers in different host machines can be attached to the same network so they can communicate with each other very easily. And this enables SOAM services and containers to communicate across nodes. Across node means containers in different locations or different host machines can communicate with each other very easily. So this removes the requirement for operating system level routing. That is an advantage. So if you want to communicate your containers with another containers which are running on a different host machine, then you don't need to worry about the routing part. So Docker will take care of that one. And this fits when you need containers running on different Docker hosts to communicate with each other. And then the Docker default network versus custom Docker bridge networks. As I mentioned earlier, Docker default network also have the bridge type driver. So it is a default bridge network. Similarly, you can create custom bridge networks too. But there's a difference between the Docker default bridge network and the custom bridge networks that you create. So let's see what these are. In the Docker default bridge network, you can use only IP addresses to communicate with each other. But when it comes to custom networks, you can use both IP and the container name. And the next point is you cannot attach or detach containers from the default networks on the fly. So to do that, you have to stop the container and recreate the containers. But when it comes to custom networks, you can do that on the fly. So another set of command examples, inspecting a network, you can use the command docker network inspect and then the network name. To inspect a container, you can use docker container inspect and then the container name. So attach a container to a network, you can use the command docker network connect and network name and then the container name. So before we moving on, let's try something again. Let's see what are the networks I have. I have two custom networks, so I'm going to remove these two first. First I need to stop all the containers. To do that, I'm going to use docker ps and docker stop, and I will give the name of the containers. And then docker rm. Okay, now my containers are removed, and I'm going to remove the network rm bridge network and bridge network 2. Okay, you can see the custom networks are no longer there, those are removed now. You can use ipaddr show command to list down all the network interfaces available in your host machine. So you can see I have three. So out of these three, there's a Docker, something from Docker. So you can see the subnet 172.17.01 and 16. As you can remember, this is our Docker default network. So I'm going to create another custom bridge network now. So I'm using the command docker network create and then the driver bridge and then network name bridge network 1, and now it is created. Now if you list down the interfaces, network interfaces available host machine, now you should see 4. You can see there are 4. This is the Docker default one, and this is the one that we have created just right now. You can see it has the subnet of 172.19.01 and 16. So let's try to find the subnet of the network that we have created here. So I'm going to use the command docker network inspect and then give the network name, and you can see it has the subnet 172.19.00.16. So that's what you have seen here. So whenever you create a bridge network, keep in mind that it will add another network interface to your host machine, a virtual network interface to your host machine. So now I'm going to create another custom network using the host network driver. I'm using the command docker network create and the type is host, and I'm going to give it a name host network 1. You can see there's an error response from the Docker daemon. It says only one instance of host network is allowed. Why is that? The reason is if you run the docker network ls command, you can see there is a host type network available. So this network is a predefined network. That means this network is created by Docker, and also you can't remove this network too. If you try to remove it, docker network rm and I give the name, it says you can't remove the predefined networks. So now I'm going to create a container and attach it to the host network. But before that, let me show you something. Let's try to see with the port 80 is open in my host machine. No, you can see it is not open. Let's open the browser and try to access the localhost port 80. I think this is from the cache. Yeah, you can see it is not working. So now what I'm going to do here is I'm going to create a container to go run and give the network as the host and itd itd and give it a name apache 1, and then the image is httpd. So I don't specify any port details, but I do specify the network as host. Let's see what is going to happen. You can see it is created, but if you run the docker ps command, you can see you don't see anything under the port section. You don't see the ports are opened, but you can see the container is running. Now I'm trying to see whether the port 80 is opened or not using the netstat command. Now you can see it is open. Now what is happening? Now let's try to access it from the browser. See, it is working now. So that means, so whenever I create a container and if I define the network as host, this container is directly attached to your host machine. It will run as a process in your host machine. It will no longer be considered as an isolated environment. This particular process or this particular Apache container is directly running on the host machine, so it does open a port to the host machine, that means to the local host. That's why now you see this port 80 is opened when you run the netstat command. I think now you have some understanding about the difference between the bridge network and the host network. When you use a bridge network, your container is not directly attached to the host machine and does not open any ports to the host machine. And when you create a container using the host network, then the container is directly attached to your host machine and it will run like a process indirectly in your host machine, so it is opened to your whole host machine. That is why you could access this container just type in the local host. Okay, now I'm going to create another Docker bridge network. I have one bridge network already, bridge network 1, and I'm going to create Docker network create, and I'm going to create the bridge network 2, and I'm going to start a container Docker run network from the bridge network 1 and give it a name. Sorry, Apache bridge 1 and httpd, and the same command I'm going to use it for the bridge network 2 and it's Apache b2. So now if I inspect these two containers and try to find the IPs, docker container inspect and Apache b1, I will grab the IP address. You can see 172.19.02, and for the Apache b2, let's try the same command, and you can see it has a different IP 172.20.02. So now if I try to access this one from the browser, you can see it is working. Similarly, if I try to access this one from the browser, you can see it is working. So now what I'm going to do is I'm going to attach this container here Apache b2 to the bridge network 1. So to do that, I'm going to use docker network connect and then the network name bridge network 1 and then the container name. You can see it is successful. Now if I run the same command again here, now you can see there are two IPs, 172.19.03, this is from the bridge network 1, and 172.20.02. Now what has happened is now this particular container is attached to two networks. The reason is when I specify the docker network connect command, it will not detach or disconnect your container from the existing network. It will just add your container to the new network, so your container is now assigned to two networks, so you get two IPs. So let's try to access this IP from the browser. You can see it is working. But with the default network, if your docker container is assigned to the docker default network, then you will not be able to use this docker network connect. You have to stop your container and start it, recreate it with the new network details. Now let's see how to disconnect the container from one network. So to do that, I'm simply using the command docker network disconnect and then the network details and then the container. So I'm going to remove this one from the default bridge network 2. So now if I run the inspect command again, you will see there will only be one IP address, 172.19.03, and now if I try to access the previous IP address 172.20.02, it should not work. I think this is from the cache. So let's try to some incognito window. You can see it is not connecting. That is because now the container is not attached to the bridge network 2. That means this IP is no longer there. This container only have now this IP. Publish in container ports. The default behavior is when you start a container in a bridge network, your ports are not exposed to the outside, basically to the host machine. So if you want to expose your ports to the host machine or to any other network, you need to publish your ports. So to do that, you can use either the publish keyword or the -p flag to expose or publish your ports. If you are using the bridge network and if you want to communicate another container which is running in the same network, then in that case you don't need to expose ports. You can simply use the other container IP and access the port. But if your containers are in two different networks, two different bridge networks, then definitely you have to open or publish the ports. So be cautious when you publish the ports, as the publish command will publish your ports to the whole outside world. So let's see some other command examples. To publish a port, you need to specify the port details here, -p, and then the left side, this is the port which is going to open in the host machine, and in the right side, this is the port inside the container. So there will be a port mapping from port 8080 to port 80. So the port 8080 is running or open or listening in the host machine, and this port 80 is running inside the container. So whatever coming to port 8080 in the host machine will be forwarded to port 80 inside the container. So if you want to specify the source IP, that is also possible. You can just simply use the source IP along with the port details 172.0.0.1 and 80.80.80. In this case, only the requests coming from the host machine will be allowed in the port 8080. What this command does is this command will create necessary firewall rules in the host machine and by mapping the container port to the host machine port. Okay, let's try this one. I'm gonna clear everything first. So you can use this command to remove all the running and stopped containers. So now if I run docker -a, there are no containers, and if I check the networks, rm, docker network rm, and I'm going to remove these two. Okay, now what I'm going to do is I have one image downloaded which is Apache image. Now I'm going to create a container, the name Apache1, and then httpd latest. You can see it is created now. If I run docker ps, you can see the port details are here. But what happens if you try to access the localhost port 80? Should this work? No, this should not. This is from the cache. See, it is not working. That is because the reason is there is no port opened in the host machine, but this port 80 is opened inside the container. So if you get the container IP, docker container inspect and Apache1, and I'm going to grep IP address, you can see 172.17.02. I'm going to access that one, port 80. You can see it is working, right? So now I'm going to create another container and expose a custom port. So I'm going to use this command, docker run itd, and I'm going to name Apache2, and I'm going to expose port 8080. So it is created now. Now if I run the docker ps command, you can see the mapping here, the port section. You can see the from the any host. 000 means from any host. So port 8080 in the host machine is mapped to the port 80 inside the container. So now if I am going here, so now if I go to my browser, and if I, before that, let me try to find the IP of this container. Apache 2, and my container IP is 1703. I'm gonna copy that one and come here. You can see it is working. At the same time, if I try to access localhost port 8080, see, it is working now. The reason is we have mapped the port 8080 to inside the container port 80. I need to show you one more thing about the networks. So now we have two containers, and these two containers are from the Docker default network. If I go inside these containers, docker exec it patch 2 bash. So I'm going to install the pin tool, apt get update y. Okay, now it is installed. So we have installed pin inside the Apache 2. So what I'm going to do is I'm going to pin from Apache 2 to Apache 1. So in that case, if we go back to our slides, here we have mentioned that if your containers are in the Docker default network, then you can only use IP addresses to communicate with each other. And here I didn't mention about this link flag. Actually, this link flag is now gonna be deprecated. It's a legacy flag, legacy option. So I'm not going to discuss about that in details, but keep that in mind. If you use the link flag, you can use the container names, but here this is gonna be deprecated in the near soon. So let's go back to our environment. So I'm going to get the IP of this Docker container, inspect Apache 1 and grep IP address. You can see it is 117 172. You can see it is 172.17.02. I'm going to go inside the container and try to pin this IP. You can see I get the reply. So what if I put the container name instead of the IP? Apache 1. You can see it is not working. Now let's create two containers in a custom bridge network. I'm going to create the network, Docker network create, and then driver is bridge, and then network name I will give b1. And it is created now, and the same time I'm going to create another container, Docker run, and network is b1, and then itd, I'm going to name Apache b1, and then the image is httpd. It is created, and the same command again, same network, I give it a different name, Apache b2, and it is created now. Now again I am going to look into one of these containers, Apache b1, exec command it Apache b1 and bash, and I'm going to install again the pin tool here. Okay, it is installed now. So let's try to find the container IPs. So now I have four containers. These are the two containers which are in b1 network. So I have installed pin into this Apache b1, and I need to find the container IP of Apache b2. I'm going to find docker container inspect, and then the container name, and give the find the grep the IP, and it is 172.21.03. I'm going to go inside the container Apache b1 again. I'm trying to pin this IP. Yeah, I can pin. At the same time, let me try with the container name. So my container name is Apache b2. Now according to the theory, I should be able to pin. You can see it is working. This is one of the differences between custom network and the default network. So if your containers are in the Docker default network, then you can only access your other containers using their private IPs. But if your containers are in a custom network, custom bridge network, then you can use the container names to communicate with each other. That's all for this video, and thank you for watching. Have a great day.